In this video, we're going to continue talking about the topics of chapter 3. Now we are going to talk about the different classifications of elements and how they share or transfer electrons in order to make compounds. First, let's establish that in the periodic table, the elements that are present are going to be classified as metals, nonmetals, and metalloids. Metals tend to be elements that are shiny and ductile. Ductile means that they can be shaped into wires. Metals tend to be good conductors of heat and electricity. As you can see, the image that we have on the right side of the slide, the metals are going to be represented by the blue boxes. Then we have nonmetals. Nonmetals tend to be dull, not shiny, brittle, and poor conductors, but they are actually good insulators. And you can see that those nonmetals are actually represented by the yellow boxes. Lastly, we have the metalloids. And metalloids are better conductors than nonmetals, but not as good as metals. And that's why they are known as semiconductors. And they are actually can be used as insulators. When we observe the following figure, we can see that there are color boxes that are going to represent each of these types of elements. In class, you need to memorize which elements are metals, which elements are metalloids, which elements are nonmetals. One strategy that you can utilize in order to quickly memorize this information is by memorizing the list of metalloids. And in this periodic table, you can observe that the metalloids are going to be the green boxes. So the metalloids include boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. You can also count element 117 as a metalloid for now. Now, once you have memorized the list of the metalloids, remember anything to the right of the metalloids is going to be a nonmetal. Remember that the only nonmetal that doesn't live to the right of the metalloids is going to be the element that we see in the top left corner of the first column of the periodic table, and that's because that is the element hydrogen. So hydrogen is actually a nonmetal. Next, left to the metalloids, every single element is going to be considered a metal. This is important to know because as we proceed in this chapter, we need to understand which elements are going to be metals, nonmetals, and metalloids, because that is going to define what kind of compounds they can make. When it comes to compounds, which remember that those are going to be substances that are made from elements being chemically bonded to one another, there's going to be two major classes of compounds that can be formed. One class is called an ionic compound. The other class is going to be called a covalent compounds. Covalent compounds are also known as molecular compounds. So first, I'm going to illustrate how do we know that we have an ionic compound versus a covalent compound by utilizing the following figure. So I'm going to focus on the left side of that red dotted line to look at ionic compounds. Ionic compounds are actually formed because the transfer of electrons between two atoms. When it comes to this figure, as you can see illustrated in the bottom of it, the capital M it is utilized to symbolize metal elements. The capital N followed by a small case m is symbolizing non-metals. So in the case of an ionic compound, as you can see, is going to be formed specifically by a metal element transferring electrons to a non-metal element. Understand that within this transfer of electrons, because the metal is going to be losing electrons, it could be one, it could be more, it is going to form a positive charge ion. Which we also call that a cation. The non-metal, because it's going to be accepting one or more electrons, it depends on the non-metal. They're going to become negatively charged species, okay? So the non-metal forms a negative charged ion, and that negative charge ion we know as an anion. So overall, when we have an ionic compound, as you can see, we have the metal that it becomes positively charged, the non-metal becomes negatively charged. Ionic compounds tend to be solids at room temperature, and when you compare them to covalent compounds, they actually have a higher melting point. Let's now look at how elements combine to form covalent, or in other words, molecular compounds. So let's now move to the right side of the slide. So on the right side of that red dotted line, we have an example for how is it that certain elements are going to be combining to form covalent, in other words, molecular compounds. Covalent compounds are formed by sharing electrons. This sharing of electrons actually permits that these atoms are going to be now having a physical link between the two, which is what we called a covalent bond. If I try to illustrate or highlight what a covalent bond looks like, it's going to be these two electrons that are shared between the two nonmetals. So to illustrate the covalent bond, instead of showing two dots that are being shared between the two nonmetals, we can also illustrate it by using a line. The rest of the dots are added to the nonmetals. Okay, we are going to learn more about covalent compounds in part 2 of chapter 3 videos. When it comes to covalent compounds, they tend to be soft, they're relatively flexible, and if we compare them to ionic compounds, they have relatively low melting points and boiling points. And again, in comparison to ionic compounds. First, we should practice to determine if I give you a pair of elements, if you can define, is it going to make an ionic compound or is it going to make a covalent compound? I should note one more thing. When it comes to this, let's understand that if you have a metalloid plus a non-metal, that is going to be, in this course, a covalent compound. And while metalloids can also make compounds with metals, we are not going to be addressing those type of compounds in this course. Next, another thing that I want to point out, that line that it represents the covalent bond may not be drawn in an ionic compound. When it comes to an ionic bond is the electrostatic interaction that exists between a cation and an anion. So there's no line that is going to be unifying the cation and the anion. What unifies them is that difference in charge of the full cation versus the full anion in the compound. Let's actually practice trying to determine if a particular combination of elements is going to form an ionic compound or a covalent compound. In order to do this, I'm going to do the first 4 problems that you see illustrated in the following slide. So we are going to do A, B, C, and D. In order to do this, it is essential that you know how to determine if a particular element is a metal, a non-metal, or a metalloid. So as we proceed, I am going to classify these elements in those groups. So with a periodic table handy, make sure that you look around the periodic table to understand where each of these elements are. So I can tell you already from reference that when it comes to oxygen, oxygen is a non-metal. Chlorine is a non-metal. If you look at your periodic table, you will observe that they are to the right of the metalloids. Hydrogen, I told you that is the only, it's exception to the rule. Even though it's in group 1A, it is the only member of that column that is actually a non-metal. So hydrogen and hydrogen, we have 2 non-metals. In letter C, magnesium is to the left of the metalloids. So this is a metal. Oxygen, as we already determined in letter A, this is a non-metal. Lastly, barium. It is a metal element because it's to the left of the metalloids. Sulfur is to the right of the metalloids, so this is a non-metal element. So as I just explained, when it comes to this, since ionic compounds are formed by metal plus non-metal, we can determine that out of these 3 problems, letter C and letter D are going to be forming ionic compounds. Covalent compounds, on the other hand, are formed by 2 or more non-metals coming together. So we can observe that in the following problem, letter A and letter B are going to make covalent compounds. Make sure that you practice at home.